Welcome everybody. Welcome to the CADEX battery maintenance presentation. So I'll go through the slides here, basically telling you what we are and who we sell to, and give you a little bit of history here too. So I'm just trying this new headset on, so hopefully everybody can hear me properly. So about us. Some of you are familiar with us, but for those who don't know CADEX, we have customers in over 100 different countries. We have a world-class team, and basically we build power, batteries, chargers, and test equipment to test batteries. We're not only in public safety, we're in other markets as well. Anything that typically has a battery application, you'll see CADEX probably involved either in the testing or maybe even in the design and build of some of the equipment. So what is CADEX? What do we sell? Here's a general overview of the CADEX solutions and our products. We basically start right from the beginning with battery pack assembly and build, chargers. I don't know if you can see the cursor. Chargers, test equipment, and then portable testers for quick testing. For public safety, you're more familiar with the charging and analyzer aspect of our business. So regarding public safety, CADEX has a long history in public safety. Public safety has been a major player of battery maintenance development. The current battery maintenance program works with radio batteries, and I got this right in front of my text here, and other portable devices in public safety. As our world becomes both more portable and connected, batteries and battery health have become increasingly critical, whether saving lives or the bottom line. Centered around the C7000 battery analyzers, we have software and other applications with adapters for different applications as well. Radios, monitors, thermal imaging cameras, all different kind of devices that use batteries will be tested on the analyzer. So let's just step back a little bit. A quick background on batteries. Over the years, battery technology has progressed chemically from nickel, from SLA actually, nickel to lithium ion now. CADEX has adapted and kept up with the industry. As it moves forward and new chemistries come into mainstream, we add it to our equipment. So the latest addition now has been lithium phosphate. So basically all commercial chemistries that are out there, we can test. Another feature that is trending is smart batteries. A smart battery can provide some information to the user. However, refresh may be needed to reset the fuel gauge or the max error flag in a battery. A reset can be done by simply cycling the battery on the C7. So what is a battery maintenance system? What do we do with these batteries? Well, battery maintenance system is a program designed to properly service and track your fleet of batteries so you can achieve longer life, reduce battery related costs, and most importantly, ensure your equipment will perform as expected. What do you need? You need a battery analyzer, custom adapters, computer software, and a label printer. And here's kind of a general overview of a system. We have a 7200 here. We have a scanner. We have the battery shop software in the PC. And then we have a label printer, printing out labels. And this is the larger 7400. So how does this work? Well, an overview is you set up the equipment, you prepare the batteries for initial testing, you identify batteries that need to be further serviced or retired, you replace the retired batteries, and then you perform the regular maintenance on batteries as scheduled. A complete service is priming batteries when they're new to put into service, testing these batteries periodically, tracking them, and then labeling so your user knows that they've been in service and when the next service date is. So here's some of the programs that we use. The auto and prime here on the left are your your typical programs you use for the maintenance system. Prime, again, for initializing the batteries, new batteries as they come in. And then the auto program basically tests the batteries that are in service. We have other programs as well for various applications here. And then we have a custom program setting where you can program the analyzer for a specific custom program. This one actually on the right side here is designated for safe air travel or transport of batteries. So again, with the battery shop software, it's a lot easier to program the analyzers. The analyzers will work standalone, so you can program the C7 standalone, but of course with a PC, it's a lot easier. And of course with the PC, you also have a database that you can actually save the data into the PC. So in here, I get this question, why don't we just date stamp them and replace the batteries every 2 years? Well, our customers need to know that traditional management of date stamping has its drawbacks. Some batteries are in constant use, others are sporadically used, and the third group is on standby. Those busy batteries may fade before the expiry date, but most might last longer. This means a lot of batteries are replaced prematurely, which increases the cost and stress on the environment. Here's a system overview here, and basically you have the label here on the bottom left. It's got the pass mark of 98%. It would have a due date on it. So when it comes back in service. So after the service, this is printed, it's attached to the battery, and the battery goes back into service with that due date. There's some easier ways to do this. We did bring in the scanner, so you can actually barcode the battery, which would have an ID specific for that battery. And then all the information is passed on to the analyzer for testing and tracked again and saved in the database. Oops, wrong way here. So that's basically the process. The whole thing improves safety and reliability, lowers battery cost, and overall higher productivity in the field. So now I'm running into some new adapters that we have. We try and keep up again with the radio market. We got different makes and models. We got Kenwood, Motorola, Harris. And this slide is kind of a general overview of some current adapters that we have both in radio. You can see some medical devices here, computing, and then tactical gear like Streamlight, thermal imaging cameras again, Bullard, FLIR. And again, we can design an adapter if needed, if the demand is there. So here are the analyzers again. We have a 2-bay for smaller applications. We have the 7400, which is your standard 2-way communication service unit. And then we have the ER, which gives you a higher voltage and current rating for some of those bigger batteries, like power tools, into the 36 volt range we can get up to. So that's basically it. So I'm going to open it up to the floor now to see if you guys have any questions.
Do you have a list of manufacturers that you guys supply that service for different makes and models for all the different batteries that exist?
Yeah, the adapter list actually is online on our website. And our website has good information too on how to use the analyzer setup. But we do have an adapter list. We're trying to get these, those data sheets I went through pretty quickly with the adapters, but we're trying to provide those on our website. So it will have, your basic information of your manufacturer, the model, and the battery used in. So that is online. And you can search online by manufacturer too. So if you got Motorola, you just put in Motorola in the search, it'll come up with the radio, or Apex, or the model as well will work.
Hey, Rocky, this is Terry. How you doing?
Hey, Terry. Fine, thanks.
Can you go into your test programs a little bit more, like the auto and the prime, and talk a
Right.
little bit about how the capacity is measured and why that's important?
Right. So you saw that label there in my presentation at 98%. So typically when new batteries are entered into service, we do a prime program. And what the prime program does, it cycles the battery. And for nickel-based batteries, cycling was really good. For lithium, cycling, and sometimes if they've been sitting a long time, is also a good thing to do. And basically, you get that battery up to its full potential. So a new battery can be anywhere from 95 to 110%. So that prime program will set that battery. You label that battery, you put it into service. Now, when that battery is service date is up, you bring that in, and what you do is you run the auto program. And auto program basically charges it and discharges it, looks at the capacity. On nickel-based batteries, it would recondition. On lithium batteries, it will just say this is a pass or fail. If it's a fail, it actually will cycle it again, and you will get a result then again. And then at that point, you're going to retire it or put it back into service. You can set your target setting anywhere from 50% or up. So if that target isn't met, you replace it with a new battery, of course primed, and you're ready to go again.
How about the reporting capabilities and maybe an agency being able to reject batteries back to a manufacturer because they don't meet a certain
Right.
capacity level?
Right. Now, yeah, the battery shop program does generate a report, a standard report that gives you the test used, the final capacity, and any other error code that would come up in the test. So actually can be used to send back to the manufacturer or the distributor and say, hey, we did this on a CADEX and we got this capacity. So it can be a warranty issue. We do have more extensive reports that have the graph of the charge cycles and discharge cycles. Some of the manufacturers like to see that too. Because they really want to know if you're if need be. Can you guys hear me, Terry? Because my internet.
You cut out for a
broke
little
up.
bit.
Yeah, my internet said it was unstable.
We caught most of that, Rockford.
Okay.
Yeah, maybe talk to what the battery shop software shows and provide you.
Yeah, so for setup, you put in the voltage, chemistry, and capacity, and you can enter that in as a model. If I was a little quicker on this, Terry, I would do that, but I'm just going to speak about it right now. But you enter that information into the database, and then you basically can barcode the battery. So you can scan the battery and then put it on the analyzer. So the analyzer runs the test. So that test information is all stored in the battery database. So you can actually store thousands of different batteries using that ID label. So once you're set up, it's pretty straightforward to service. Basically, the battery comes in, you scan it with the gun, you put it on the analyzer. There's no more programming involved once you set it up properly. Your biggest step there is setting it up, labeling all the batteries with the correct ID label. But once that's done, it's pretty straightforward on servicing the batteries. Any other questions?
Rocky, can you talk to the new technology that you're bringing on board, the new chargers and
Right.
days?
Yeah, Terry, I'm hesitant always that because as a sales guy, I get in trouble introducing new things before they arrive. But we are developing a charging system that deals with. In my slide presentation, you saw the smart battery. So we're coming up with a charger that actually can read the electronic fuel gauge in the battery, as well as deal with the chemical part of the battery as well. So um, it's a device that you can basically put the battery on, that the charger will read the battery, will charge it correctly according to the battery spec. Um, any error code or any of that will also be detected. And eventually it will be connected to the web and the cloud. So that information for that battery, which has an internal ID, would be stored in the cloud. So moving away from software more to a cloud-based system where the testing and the charging performance is all uploaded. So yeah, we're coming out with it's a quasi analyzer charger. So that's where we're going with that. And timing. That's probably the next thing you're going to ask. That probably within 12 months we should have something available to show.
All right, we've got a couple more minutes if anyone else has any questions or comments. Rockford, do you guys have any typical cost benefit analysis? You talk about being able to save money by not spending money that you don't need to on new batteries. You talk about
Right.
Not putting batteries or radios into operational risk by putting things out there that only last 6 hours or whatever.
Right.
Do you guys have and of course, each agency is different and also
Right.
different manufacturers. Do you have a general cost benefit analysis study that you could provide to the group?
Well, we used to have a formula that we worked on with nickel-based batteries because with nickel-based batteries, you could recondition them and bring that to light. And it was pretty consistent. With lithium, you're right. You're all over the map, depending on how it's used and the application. We have some cities and some states that have issues with their radios. They only last a certain period of time, and there's a heavy wear on the battery. So, if they're testing the battery, the most critical issue is making sure that battery lasts as long as it can in the field. So that's an issue for sure. The cost benefit of throwing away a good battery typically is a general application where people are just date stamping them. They're replacing them every two years. So what you do then is, if you can consistently save that battery, say 6 months or maybe another year, I've had people using it 2 years without replacing it, 2 extra years. So that's 2 extra years of saving, battery savings for a state or a city or an agency. So again, it depends on the application, the quantities, and that type of thing. Ambient temperature too. Florida, your southern states, a lot hotter, a lot harder on the battery. So those are all things you can look at. But if you start the process and you see that, hey, this battery is lasting a lot longer than it's supposed to, you can qualify that pretty quickly.
Okay, excellent. Thank you, Rockford. Well, that concludes our presentation with CADEX Electronics. If you're staking in Exhibit Hall B, we will be presenting with TC Energy's distribution next, and we'll be starting that